All right, so we got a new problem set here. We are mostly focusing on mechanical advantage for the first part. And mechanical advantage is the advantage you get from using the machine, right? So that's taking the name and kind of using the words to define themselves. But it's how much easier it is to pick something up when you've got a setup compared to just using your bare hands. And typically the trade-off is that you move a longer distance with a smaller force. And so if we look at this and the first question's about a lever, we're pulling on a long lever arm to make a small movement on the other side, but the benefit is that we can pick up something heavy, right? So think of Wile E. Coyote from the cartoons, or something a little more modern day, like using a jack to pick up a car. You pump the handle several times through several feet of an arc, then you're only bumping the car up a few inches overall. So mechanical advantage is the value of it is actually going to come from the ratio there. So your input length, so wherever you're putting hands and putting effort in order to make this thing move, divided by the output, which is the load or the heavy thing that you're trying to pick up. Where we have to be careful about this for a lever in particular is that you never, for this class of lever, use the whole lever to do the same job, right? So think of, again, Wile E. Coyote uses a big stick, uses a small rock to create a fulcrum or a pivot point, and then pulls on one side, lifts with the other. And so what that means then is that the full length of the lever is going to be broken into pieces where you've got your input length and your output length. And so as it turns out, we only have one of these numbers that we need. We have to break down and go ahead and find the other one. Okay. Then if we look at this carefully, we have different units on our values here. So that's something we're going to want to take care of soon. In the end, it doesn't technically matter whether you use all centimeters or all meters, as long as they match each other. Now, meters is typically considered standard length, so we can be consistent and match that. It's really not going to matter either way. So I don't know. I guess let's use meters. So from right here, think about cents, like cents to a dollar, pennies in a dollar. It takes 100 centimeters to make a meter. Because the 100's on the bottom, we're going to end up dividing. Because it's talking about the load here, that's where we're trying to put out force. So that's our output length. And dividing that's going to give us 0.2856. Okay, so we have one of the numbers we needed. We need to find the input length. Well, this formula we set up with the beginning, I hope, is a big clue. We know that the entire lever, the big stick being used as a lever, is 2.46 meters. I don't know how much of that is on the input side of the setup, but I do happen to know that 0.2856 meters of it is on the output side. And so there's only one thing here that we don't know. So it's addition right now. We can use subtraction to get rid of that number. We can clear it away and we can find out what our input length is. Once we have that, then we can plug back into our formula. So our input length here, this difference ends up being 2.1744 meters. All of our values are present, so we can take and plug them in. This one goes here, and this one goes here. The units, because they were made to line up with each other, are just going to cancel. When we take meters divided by meters, we're not going to have anything left. And that's by design anyway. Mechanical advantage is just some number for how much help you get from using a system. In particular, this one looks like it's going to be 7.61. If you ever work one of these questions and you notice that you're exactly one off of an answer choice, it may be that you forgot to do the subtraction part. As it turns out, because of the way that gets subtracted, we end up also going back and dividing by the number. If you take the numbers from the question, divide them originally, then typically you're off by 1. So in theory, if you were paying attention, you could technically use that as a shortcut. Divide them incorrectly like you're not supposed to, but then just adjust at the end by subtracting 1. So here we found the proper numbers. We just directly get 7.61.